In the late summer of 1977, a small spacecraft rose from Earth's surface, carrying with it more than instruments and sensors. It carried the hopes of an entire species. That craft was Voyager 1. At first glance, it was nothing extraordinary, barely the size of a compact car, built from metal, wires, and fuel. Yet it would soon become the farthest and fastest emissary humankind has ever launched into the cosmos. Racing through space at nearly 17 kilometers per second, Voyager covers more than 1 million kilometers every day. And still, in the scale of the galaxy, it is moving with the patience of a drifting leaf upon an endless sea. To reach even the nearest star will take 40,000 years, a span longer than the whole of human civilization. What keeps this mission alive is not its speed, but its symbolism. Voyager is our message in a bottle, carrying golden records with the music, voices, and essence of Earth, an introduction to who we are. And as it ventures further from the warmth of the sun, one question rises above all. What awaits this solitary traveler at the very boundary of our solar system? I'm James, and this is the Space Science NTH, where we journey together into the mysteries of the universe. And if Voyager is humanity's lone traveler, then its destination is a frontier unlike any other, a place we have never seen but are certain exists, the Oort Cloud. Imagine a sphere of frozen debris so vast it could swallow the solar system many times over, a shell of icy fragments extending more than a light year from the sun. It is not a planet, nor a simple belt like the familiar rings of asteroids or the Kuiper Belt beyond Neptune. Instead, it is a ghostly cocoon, a veil of trillions of icy worlds scattered in every direction, forming the true outer boundary of our home system. From this perspective, the sun itself shrinks to little more than a bright star among countless others. Its gravity is stretched thin, barely holding on to the farthest pieces of this cosmic shroud. What makes the Oort Cloud so compelling is its paradox. We have never seen it directly, and yet its fingerprints are everywhere. Every long-period comet that it shrieks through our skies, blazing tails across the night, testifies to its existence. These ancient messengers emerge from the cold, deep freeze and dive inward, their journeys taking thousands or even millions of years. The Oort Cloud remains hidden, invisible to our telescopes, but it is the most accepted explanation for these celestial visitors. It is, in every sense, the silent edge of our solar system, the boundary between the known and the infinite unknown. To understand how such a colossal shell of ice came to be, we must return to the earliest days of the solar system, more than 4.5 billion years ago. In that era, the newborn sun was surrounded by a swirling disk of gas, dust, and rock, the raw material from which planets and moons were forged. Most of this matter was gathered into the familiar worlds we know today, but not all of it found a stable home. The giant planets, especially Jupiter, acted like celestial slingshots, hurling countless icy planetesimals outward. Some were cast away entirely, lost to interstellar space, but many lingered at the edge of the sun's reach, where the pull of our star was just strong enough to keep them bound. Over time, they formed a vast halo, suspended between the gravity of the sun and the tides of the Milky Way itself. The Oort Cloud is not uniform. Astronomers believe it has two distinct regions, an inner reservoir known as the Hills Cloud, denser and closer, beginning around 2,000 astronomical units from the sun, and a far more diffuse outer shell stretching to as much as 100,000 astronomical units, a distance so great that light itself takes over a year to cross. Within this cosmic cocoon, objects drift in random directions, not aligned like the planets on a flat plane, but scattered like fireflies across a night field. Their orbits are fragile, easily disturbed by the passing tug of nearby stars or by the slow tides of the galaxy, events that can send one of these icy fragments tumbling back toward the sun as a comet. It is a structure both ancient and dynamic, built from the debris of our own beginnings and perhaps enriched by fragments from other stars that once formed alongside the sun in its stellar nursery. If true, then every comet that falls inward may not only tell the story of our solar system, but also carry whispers from other suns long vanished into the galaxy's depths. From time to time, this distant reservoir sends a visitor back to the heart of the solar system. We call them comets, icy relics from the deep freeze that blaze to life as they approach the sun. Their frozen surfaces, preserved for billions of years, awaken in brilliant displays of gas and dust, forming luminous tails that stretch across our skies. These are not random wanderers, they are emissaries from the Oort Cloud, carrying within them the chemical signatures of an ancient era when the planets were still being born. Some of the most remarkable examples have etched themselves into human memory. Comet Hale-Bopp, seen in the 1990s, shone so brightly that it remained visible to the naked eye for 18 months, the longest of any comet in recorded history. Comet Lovejoy, discovered by an amateur astronomer in 2111, dared to graze the sun's corona, surviving the fiery encounter to become a dazzling spectacle in the night sky. And Comet Siding Spring, detected in 2013, passed so close to Mars that it showered the planet's atmosphere with material, allowing us a rare glimpse of its hidden chemistry. These comets are more than cosmic fireworks. They are messengers, revealing the invisible presence of the Oort Cloud and hinting at its immense scale. Even more intriguing, some scientists suspect that many of these icy bodies did not form here at all. If the young sun once shared a crowded stellar nursery with hundreds of other stars, then fragments of their worlds may have been exchanged, scattered, and captured. This means that the next comet we see streaking across the heavens could carry within it material born under an alien sun. Every bright tail across the night sky is not only a spectacle, but a reminder that our solar system's edges are interwoven with the history of other stars. Even though the Oort Cloud has never been seen directly, we know that 5 human-made machines are now on a course toward it. Voyager 1, Voyager 2, Pioneer 10 and 11, and New Horizons, all of them will eventually cross into this frozen frontier. But the distances are so immense that it will take centuries just to reach the inner edge, and tens of thousands of years to pass through it. By then, their voices will be silent, their instruments long dormant, drifting forever as relics of our first steps into interstellar space. In the 1980s, scientists dreamed of a probe that could fly 1,000 astronomical units in just 50 years, a mission called TAUAU. More recently, a proposed project named Whipple imagined using advanced telescopes to detect Oort Cloud objects by their faint shadows against distant stars. Neither vision has yet left the drawing board, but the ideas remain alive, waiting for the moment when technology and imagination meet again. One day, perhaps, humanity will not only infer the Oort Cloud's existence, but see its icy fragments directly, touch them, and bring their secrets home. Until that day, the Oort Cloud remains our invisible boundary, both real and symbolic. It reminds us that Earth and everything we have ever known lies within a fragile bubble, dwarfed by the galaxy beyond. Yet it also reflects something profound, our willingness to reach, to wonder, to send a tiny spacecraft into the dark with a golden record that says simply, "We were here." The Oort Cloud is not just the edge of the solar system, it is the mirror of our own curiosity, the horizon that calls us forward. And as long as we dream, the journey toward that horizon will never truly end.